Okay, good morning. Welcome to
FamilyMath946.
FamilyMath946. So, this is a neat tweet I just happened to see this morning on an unsolved problem. It's called the lonely runner conjecture. So, n runners on a circular track of length L start from the same spot with constant and distinct speeds. Okay, so everybody starts together and they all run at a different speed. A runner is lonely if the distance from everyone else is at least L over N. So L is the length of the track and N is the number of runners.
Alright.
Okay. A runner is lonely if its distance from everyone else is at least L divided by N. The lonely runner conjecture is each runner is lonely at some point in time, but it's only proved for n less than or equal to 7, and I think when they turn yellow here is when
They've been lonely.
Okay, so here's how it plays out. So I want you to just watch and tell me what you're saying. Why don't you go first? Tell me what you're saying.
Well, see, looks like there's some fast runners and some slow runners here. It's just not sure which ones get lonely first. So it looks like the second fastest and the third fastest get lonely fastest, and then it looks like the slowest two then get lonely.
Okay. What do you?
Yeah.
What do you think?
It looks like the fastest guy, who's this guy right there.
He doesn't get lonely
he's the
until the end.
last person who gets lonely.
Okay.
And it looks like, so whenever they get lonely, there's a pair or a group of three of runners that is spaced out evenly along the track. Like you got one runner, then a space, and then another runner, then an equal space, and then a third runner.
Oh, that's interesting.
That's how they would get lonely, and that here it happened with 4 because you had 1, and then these 2 in the middle got lonely, and there's 1 over there.
Okay, so let me ask you this question. So in this example here, the fastest runner seems to be the last one to get lonely. Do you think that's always going to be the case? That the fastest one is the last one to get lonely?
Well, I think it could be the case, but also maybe if the fastest runner is a lot faster than the other runners, like they have to be at distinct speeds, but they don't have to be at the same intervals.
Huh.
So maybe if all of the other runners are really slow and this runner is really fast, he could just zoom ahead and could become lonely at first.
Okay, what do you think?
I think that it depends on how much faster he is. Because like here he's a lot faster than everyone else. So he gets around to the other side of the track to the slow guys before the second fastest guy gets far enough away from him so he would be lonely.
Mm-hmm.
Or I guess when the second fastest gets far enough away, he's already close enough to the slow guys so he can't be lonely. But if they were all like kind of the same speed and they didn't differ as much, he might not be the last one. Like he might be the first one to get lonely.
Interesting.
Like if the slow guys were a bit faster.
Okay, so we're going to try to tackle this problem in the 2 easy cases, see if we can figure it out for 2 people and 3 people, and then I think even at 4 people it starts to get very, very difficult. But hopefully we can tackle the n equals 2 and n equals 3 cases.
Okay.